Before we can actually crack passwords, we first have to gain access to that password. In the Windows operating system, you can store passwords in two separate methods. The old method was called the LAN manager or LM hash. It kept the password to a maximum length of 14 characters and placed them all in uppercase format. The method has been disabled in Windows Vista and later operating systems. Now, Jeff, what's a new method of storing passwords?
Glad you asked. The method used today is an NT hash, which has a maximum length of 127 characters and will allow mixed case. The NT hash that is used today is the second version, which doesn't utilize the MD5 hash algorithm. The LM hash had another unique characteristic. It would take the 14 characters and then split them into two 7-character passwords. These two would then be encrypted separately and then brought back together to form a single hash. Now, this made for a very easy to crack set of passwords. They should have been disabled this long before Windows Vista, but at least it isn't used today, so that's good news. But some environments, like some of the banking institutions where we perform penetration tests, are still utilizing the LM hash due to backward compatibility of various systems within their environment.
Yeah, thanks, Jeff. Now, within the Windows operating system, the passwords are stored in what's known as the SAM database, whereas in the Active Directory server, the passwords are stored in the AD database. Once the database has been copied or stolen, tools such as John the Ripper can extract the hashes from these databases. A tool like Cain and Abel, which you see here, can also extract those passwords from the SAM database, and Cain can also be used to crack passwords, just like John the Ripper.
Cain and Abel is one of the best cracking tools available on the market today. We will utilize this tool to crack LSA passwords, which of course are the hashed passwords of the local Microsoft account. Now, we have Cain and Abel open, and we will select the Cracker tab. The first thing we must do is delete any existing records already stored. So, we simply right-click and remove all, we say yes, and we move on. Now, in this exercise, we will get a focus on the LM and NT-LM hashes. In order to extract the local passwords, you have to highlight the type of passwords you want to work on, and then we click the blue plus at the top to add the local LSA hashes. Cain and Abel has the capability of importing the hashes from the local system, hashes from a text file, or even importing hashes from the SAM database. If we did extract the SAM database from another system, we can import them here and pull them into Cain for cracking. We are going to import these items from the local system. So we choose the radio button to import the local system, and we click Next, and then we wait for the accounts to populate. Now you can see here that we have 3 accounts with the admin account, the administrator account, and notice here under NT password it says that it's empty, which means there is no password for that account. We also have the guest account, as you would expect, and it also has no password. So let's expand the LM hash, the NT hash, and we can see here that the LM hash is the same for all 3 accounts, even though the admin account does have a password. This is because we are working with Windows 7 and the LM hash is disabled by default, so it is not in use, and therefore there is no LM hash stored for the admin password. So, let's get cracking. Right-click on the NT hash that we want to crack, and notice that we have a few easy ways to try to crack this password. One is the dictionary attack or the brute force attack. Now in this example, we are going to choose brute force attack, and we have to click on NTLM hash. Note this stage you have to define the character set, and notice we have many options here, and you choose the option based upon the password policies of the company, including the minimum length of the password. We can also create a custom list. We can set that minimum length, and in this case we are going to choose 6 for a minimum length of the password. And of course we could change that password length, that maximum length as well, but we are not going to do that right now. And then we simply click Start to begin the cracking process. Now notice that the time left to find the password is very large. We are talking many years. Now we cannot sit around obviously and wait for the brute force to happen on this particular system, so we're going to do something different here. So let's stop this crack. Now let's go back and try a dictionary attack, which we would use if we have a strong dictionary file that likely has passwords for this particular user. We'll choose NTLM hash. Again, it would, as you would expect, this attack does need a word list, a text file, and this text, of course, this file is possible passwords that will then be hashed and compared to the extracted hash that we have already stolen. We had already chosen the password list, but we can right-click and select to add another one, but we will not need another one, so we will go ahead and just cancel this out. For demonstration purposes and to make things go a little faster, we of course included our password in the list. And we simply leave the defaults and click Start, and of course it didn't take very long because we knew the password ahead of time, and while there is one of one hashes cracked. This took less than 1 second, and as you can see that the password is, well, it's LearnSmart. We chose to exit, and now we see that K is populated the NT password area with the cracked password. So that is your simple demonstration on the use of Kane with both dictionary and brute force attacks. Now, one of the reasons that the brute force attack was going to take so long is simply because the system we're running on this is not very powerful. It's not a very powerful computer. We had used a system with a 25 graphic processor units in it, and it would have taken less than 6 hours to crack this password using that same technique. So enjoy your cracking. Because some of the hacking tools are able to crack passwords so quickly, Microsoft introduced a more secure method of storing encrypted passwords. With the introduction of Service Pack 3 on Windows NT 4, yes, we are going way back now, Microsoft introduced what's known as the sys key for added security. This utility will add a 128-bit encryption to the SAM database, and the decryption keys are found in the system file. So if a hacker steals the SAM database, they would not be able to open it without the sys key. Now, hackers then develop tools like BK Hive that can extract the boot key from the system file so that the SAM database can be decrypted. Tools like Cain and Abel will also do this for you. So one very nice mitigation technique is to move the sys key to a location not on the local system. However, and Laura, you may laugh at this, but the only supported method to move the sys key off the local system is to place it on a floppy disk. You remember what those are? You're too young to know what a floppy disk is.
I actually do.
How many of you have those laying around? Anyway, Microsoft has not yet updated this feature, which is interesting, as you would expect this could be a nice additional security mechanism if it utilized newer technologies such as a USB key.
USB, not a floppy?
Yeah.
Now, salting is a method that can be used to change the standard hash of any password to something unique. You can make common passwords that are identical have a different hash by adding an additional value to the hash when encrypting it. A common example would be to add a 12-bit salt value, which would increase the search space of an MD5 hash by 4096 values, or 4096 values. This can help to defeat an attack called the pre-computed hash attack or rainbow table attack, which we will look at later. Now, the first example below has 3 users, but only 2 different hash values. Notice user 1 chose hello as a password, as did user 3. You laugh. In a normal hash algorithm, these 2 passwords would be identical. The second hash value is different because the input is different. Now, when we add a salt value, or salt values, let me correct that, as the bottom graph demonstrates here, every user has the exact same password, but the salt value is different for each user, and therefore the end result of the hash value is unique for each of them, making it very difficult to crack the passwords with the methods hackers generally use.
Yes, and thanks for all that information. That was a lot of stuff there. However, I do want to warn everyone that there are a lot of inaccurate posts on the web regarding the topic of salting in a Windows operating system. Now, just know this. It is not possible to salt passwords in a Windows operating system or within Active Directory. It's way too much complexity built into the authentication mechanisms to use a salt value.
Thanks for bringing that up, Jeff. I kind of like knowing that. Now, if you wanted to use a salt values for web applications, we recommend that you don't utilize MD5 or SHA-1, as they are weaker hash algorithms that have been cracked. Instead, make use of SHA-256, SHA-512, RIPE-MD, Whirlpool, or SHA-3. That was a lot of them, but I hope you maybe caught them. Now, in order for salting to happen on a web application, you have to code that into the program, and the simple steps are listed here. You would first generate the salt value, append that to the password, and then, of course, hash the two together and save it in the database. Now, to validate that password is a little bit trickier since we have a different hash value for the different users. You would first retrieve the salt and the hash from the database, then you would append the salt value to the password provided by the user and run the hash algorithm again to verify whether or not they match. Though this method is quite nice and aids in preventing rainbow table cracking techniques for passwords, it is seldom used.